This example is a lot more likely of something that you'll come across in your field once you graduate. And here's just a bunch of data. The crime rate per 1,000 for a random sample of 46 Denver neighborhoods. Now, because there's a sample of 46, we know that the sample size n equals 46. We also can recognize that that's greater than 30, so this is a large sample. The sample is large enough because it's greater than or equal to 30 for us to apply the central limit theorem. So we can say that the distribution of sample means is going to be approximately normal. Therefore, because we don't have sigma, we can still use the t distribution to create this confidence interval. To do so, we need to know the mean and the standard deviation for this values, or for this data set. So you can do that by entering the data into list 1 in the calculator and then running one variable statistics on list 1. It will kick back a number of summary statistics, including that the mean is about 64.2 and the standard deviation is 27.9. We're going to need those to create the confidence interval. The confidence level is 80%, so that thing will tell us the critical value of t. To do this, we need to know the confidence level, like we said, 0.80, but also the degrees of freedom. If the sample size is 46, the degrees of freedom is 45. So we need a t value from the table of 80% confidence and 45 degrees of freedom. 80% confidence is this second column here, but I need 45 degrees of freedom. So to scroll all the way down, see what we can get. 45 is right there on the table. That's very nice. If it was not 45, if we had 43 degrees of freedom or 44, we'd round to the next lowest degrees of freedom to keep it conservative. So if I hit 45 right on the head, I'm going to use 1.301. If I had 42 or 41 or 43, I would go down to choose 40 to be the most conservative. See how that t value is just a little bit larger, so my confidence interval will be a little bit larger, but I'll make sure to get that level of confidence by using it. In this instance, we can use 1.301, it's right there on the table. So this is 1.301. Now to make this confidence interval, we need the three things, right? The point estimate, the best guess that we have for crimes per 1,000 is the sample mean, which was calculated to be 64.2 crimes per 1,000. The second thing we need is the margin of error. Because the sigma is unknown and the sample is large enough, we can use the t distribution, critical value of t, sample standard deviation divided by the square root of the sample size. Put in the information we have there, the critical value of t, 1.301. Standard deviation is 27.9, and we'll divide that by the square root of the sample size, which is 46. Kick that into your calculator, you get a margin of error of 5.35. So the third step is to take that margin of error, add and subtract it from the sample mean, right? X bar plus or minus margin of error will create a lower bound and an upper bound. The lower bound, of course, is where we subtract, so that's 64.2 minus 5.35. for a lower bound of 58.85, and the upper bound is 64.2 plus 5.35 equals 69.55. Check the software or the exam or anything for any instructions on how far to round. All this information was to 1 decimal place, but so by using significant figures, I'd be comfortable rounding this to 1 decimal place, which is why I only took this to 2, just enough to give me the correct rounding ideas here. So I'd say that this was from 58.9 to 69.5 goes up to 70.0 for the lower and the upper bound to 1 decimal place. We can interpret this. If we're advertising and a neighborhood has a crime rate of 57 crimes per 1,000, we can see that that is below the average because we think that the true average crime rate is somewhere between 58.9 to 70, and 57 would be right here before that, so that's below average, and so maybe we could lighten up on the patrols in that neighborhood. Alternatively, if someone or one neighborhood had a high incidence of crime or something that we see to be above the true population average, is well outside of our confidence interval, then maybe we would need to assign more patrols to this neighborhood. So that's just a nice short example of how we can use information from confidence intervals to make decisions. I also thought you would like to know how to do this in the calculator. He's pre-built the TI-83 or 84 with ideas about how to make these confidence intervals. He already knows the margin of errors. You just have to tell it what type of interval you're running. All those are found. Let me pull up my calculator. We can find the intervals under Stat and scroll over to Tests. So that was the Stat button. Over to Tests. We don't want to run tests yet, so we're going to scroll down until we see intervals. You'll see that the first interval is a Z interval. We did that in section 7.1. We do that when sigma is known. Then there's a T interval. We do that when sigma is unknown. And that's what we did in this section. You'll see that there are other intervals also. What happens when we have a 2 sample or when we have a proportion. Keep scrolling down. We'll use those in this class as well. 1 proportion Z interval or 2 proportion Z interval when we're comparing 2 samples. This is in section 7.3 from this textbook. And then 7.4 uses 2 proportion or 2 sample Z ints or 2 sample T intervals. All of those are in 7.4. Right now we have a T interval, so we can go up and select T interval. It's all menu driven. It'll just ask you for the information it needs. We're going to put in data if the data is in list 1, so if you already put all those big numbers in up here, this data set in list 1, you could tell it to run right from the list, or we could put in the summary statistics if those are given. We assumed the mean to be 64.2. The standard deviation is 27.9. Sample size was 46, and the confidence level was 80%. Then that gives back the T interval for this information. A couple summary statistics just so you can make sure you entered those correctly, and we see that we got the right value, 58.85 to 69.5. So if you round the 5 up, it goes to 6. Yeah, you probably were all wondering about that, huh? I was having a moment of mistake, 69.6, not 70. My apologies. So anyway, there's a good example of how to check yourself using your calculator.